Thanks all that you are today with us. And I'm Laro, the chapter leader of OWASP Timisoara, and hope that everyone is well prepared for the summer vacation. And before summer vacation, you will want to find a couple of cool topics like Recon, vulnerabilities, bug hunting. And today we have with us two special guests, which will talk to really cool topics. So Daniel Tomescu, it's the senior manager from KPMG and Untitled Hacker. So he says that he's a bug bounty hunter by night and a curious security researcher. And it's a senior manager, an ethical hacker at KPMG. And I will really look forward to see how Daniel will convince us that you need to work harder in a world that actually states that you need to work smarter. So I'm really looking forward to see the arguments of how can we not be biased by the society, basically. And why not try harder, working harder. So and also we have with us Alexis, which it's a red teamer at Visma, and also a pen tester, a bug hunter, and also he's author of pen test book. I'm really glad that both of you are today with us, and we'll get lots of recon tips and also automation, most probably from Alexis, and some the counter argument from Daniel. So I'm really looking forward to this this talk. So before jumping into the actually the presentations and to this all, I will just want to highlight that we will have a couple of new events in September. 1st September, basically it will be the OWASP Global AppSec Asia, and this month in the 6th we had the OWASP Europe, and in September also we'll have the OWASP webinar. So if you want to have more insights into the events or to the other virtual events, then just check that link. And now I'll leave the stage to Daniel, and I'm really looking forward to your talk and to your presentation, Daniel.
Thank you for the introduction, Katalin. Just 1 second to see how I can share my screen.
Works.
Okay, so the introduction was pretty to the point. I was not sure this would transform into an argument with Alexis and his way of putting automation and reconing first. But yeah, basically I will try to explain why sometimes that is not the best approach, at least with a few examples. A bit about myself. As you mentioned, I work with KPMG Romania for over 8 years now. And I'm from the very beginning, I'm focused on discovering vulnerabilities, on being a penetration tester / ethical hacker. Besides that, my formal education is as an automation engineer from University Polytechnic of Bucharest. So if anything, I should understand automation and make use of it, not make an argument against it. But yeah, we'll see. I have a few certifications. The first one mentioned in the list is from offensive security. He's really focused on web vulnerabilities and source code review. And this will help during the presentation a bit. And nevertheless, if you know me from other environments, let's say from the Romanian security team or HackerOne or other places, you probably know me as the Time. I try to keep this handle everywhere I go. You mentioned where my interests are in this part of finding vulnerabilities, mainly in web applications. And I do so by day at KPMG Romania and by night working in bug bounty hunter, bug bounty programs. But yeah, it's really funny for me to say that I'm a bug bounty hunter, because most of the time I only find cross-site scripting vulnerabilities or anything that is not as impressive as you find on NetSec or let's say HackerOne's latest disclosed vulnerabilities. But nevertheless, even from smaller bugs, sometimes you can make nice exploits and nice vulnerabilities. Anyway, about today's topic, I'll try to explain what is the challenge and why working harder is needed, at least in what I do. I'll try to define what is the smart way, or at least how I see the smart way being in finding vulnerabilities. What is the hard way and how this differs from the smart way. I'll try to show a few cool findings. Some of them I've already showed during DEF camp, but a few are brand new. And when I say brand new, I mean that one is from a few days ago, and one is not yet ready to be disclosed. So it's, let's say it's still a secret. And yeah, a few mentions regarding how we can get better at this, or even get lucky. If getting lucky means also that you can get lucky by doing it with purpose. Okay, so what's the challenge? Why working hard is needed? In my day job at work, I am testing a lot of enterprise level solutions which have been tested before. Those solutions have seen Nessus before, have seen Qualys. They were probably scanned with a lot of source code scanning tools. If there is anything that an automation tool can find in these applications, probably the client already knows about it, and there is not much added value I can bring with only scanning, with only using vulnerability scanning tools, right? Even more than that, even if I can find some vulnerabilities by manually testing the application, sometimes there is the case that I test the same solution year and year again in recurring testing. And if I found anything last year, it's already patched, it's fixed, and I cannot use that anymore. So it's a really hardened environment. It's basically more than you can see in an application that is at the first time penetration test, or that has barely seen the day of light. Other than that, another challenge that I find often is that the scope is really fixed. The scope is defined in a letter of authorization, being a few IP addresses or a few functionalities within an application even. So I do not have the luxury of exploring outside of the scope and seeing, let's say, if other components or other dependencies which are seemingly not related, if those could impact the security of the solutions I test. And in the end, if that was not enough, also those solutions are protected by enterprise level defenses, be it web firewalls. There is also always a CAPTCHA which prevents you from automating what you want to do. A lot of protections which make our life harder, right? So that's a challenge at work, and in bug bounty, it's even worse, if I may say, because everything that is low risk or medium risk is out of scope from the very beginning. You cannot go report a bug in a bug bounty program, something like clickjacking, without a clear exploit. You cannot report any vulnerability regarding missing headers or outdated libraries or anything like that if you do not have a proper exploit for that, right? So anything that is easily reachable is out of scope. And even more than that, in high-paying bug bounty programs, there is a lot of competition. I'm not the first one to see the solution. I'm not the first one to hack on that target. A lot of people smarter than me have already took their chance in that solution. So what I can do is maybe try to put more work into it. I don't know. So what's the smart way of finding vulnerabilities? Probably just like yourself, I watch a lot of presentations, successful presentations from DEF CON and other conferences, where everybody insists that the way forward in those programs is to enumerate more and enumerate more and enumerate more. And when you have done enumerating, you put that in a loop and do that daily. And well, this is it. You enumerate more and more. And of course, you do that in an automated fashion because you want to let the tools do the work for you during the night when you sleep, and during the day, you just find vulnerabilities. It doesn't really work for me, at least not in very hardened environments. But well, this is it. Even offensive security slogan, the try harder, when actually taking the certifications, you can understand this try harder as enumerate more, and but you will probably at some point have enough information about the target so that you can hack it, right? I'm not against this approach. I really love the automation part, and enumeration has its place. But the problem I'm seeing with this approach alone is that sometimes we forget that it's not only about enumeration, but also learning something about the environment while you do so, right? Because the more information you gather about an environment, the more you know how to hack it, at least in my experience. The hard way is not as flashy as the smart way. It's really boring, actually. You basically have to focus on understanding the target. You cannot hack a solution if you do not know what the main functionalities are, what is the main security risk. For example, in some solutions, getting access to client data may be a big risk. In other solutions, maybe you don't have client data at all, so you should focus on different things. More than that, it's about the same, try harder and not give up easily, especially if you find something that is at first not a very high risk vulnerability, but you should insist on how you can turn that into a real issue and how you can exploit that. And in the end, you really have to prove that what you are finding and what you are reporting is a security risk, because without a proof of concept, not a lot of people will believe you. And you will have more challenges explaining the vulnerability than actual success, right? So the hard way also involves, in my opinion, building a reliable proof of concept, one which can really highlight the vulnerability to the client or to whoever is interested in fixing it. So let's start with a few findings, because I know you are not here for talks regarding how to do it, but for actual findings. This first finding is really recent. So one of my relatives asked me to help them with a booking confirmation for their holidays on the seaside. Of course, I am the IT guy and I know how to do IT stuff like booking online. So yeah, I found some interesting websites. One of them was really useful, looked very well, had a lot of functionalities for searching for holiday stays, for hotels, and so on. You could filter by a lot of search criteria. For example, maybe you want to have a pool at your stay or anything like that. It was really useful. And on the other hand, when I was searching for a stay, I got this feeling that the website is really secure because they did not request too much information for me to make that booking. They didn't even ask me to create a user account or anything like that. Just search for the hotel that you want, make the reservation. You have to insert your data and credit card details, but that was it. No useless subscribe to an email or anything like that. Nothing that would scream like a security risk right there, right? So after booking this this holiday, I've got this email with a confirmation that the booking was successful, and I was really mad to see it. Maybe if you have an eye for those types of problems, you can already see just from this URL what is the problem and what is the vulnerability here. For me, it was like a first scare when I saw the URL. But let's see what they display on by clicking on the URL. So basically, they say something like, "Hello, the time your reservation is successful. Here is all the data that you introduced, except for the credit card that was not displayed in the confirmation." But basically, you could print this this message, and with that, you could go to the hotel. And yeah, there's that. But the problem here is that at any point, I did not make an user account. And I could see that simply by clicking on link in the email for accessing this confirmation page. This would not disappear after first click or anything like that. This is still online. And the problem here is if I can see it without a user account, without authorization, then anybody else can see this this confirmation. And if you look closely into it, the only identifier for this reservation is a numeric identifier, which can be easily brute forced. For example, if we modify this and downgrade it by 1, we can see the booking of another person. And Vasile was really the first person to pop out in this search. So this is a very classic example for an IDOR. It's not a flashy vulnerability, nothing juicy, simply a poor implementation. I've tried reaching the website owners for reporting this vulnerability. All I managed to do was to give my details and to get a promise from a nice lady that somebody from IT will ping me back, but it hasn't happened so far. Yeah, at least now I have access to thousands of reservations and client data. It's a sad story, actually. Hope this will be fixed soon. But what are the takeaways from this vulnerability? Well, my first impression is that IDOR vulnerabilities are somehow hard to be found by security scanners, at least by the security scanners which are not very well instructed in what should be public, what should not be public, and what should be accessible by a user and what should be out of the user's reach. In the end, IDORs are a security vulnerability because you ask this question if you should have access to that entity, but this is a kind of a business logic question, the type of question which you can only answer by understanding the application and knowing which data should be accessible to which users, right? And these types of questions are not easily answered using automation or enumeration. And this is something which might be really obvious to a new human eye, but not that obvious to a security tool, right? And it's not just IDORs, it's the whole part regarding authentication and authorization. Those types of vulnerabilities, from my experience, are notoriously hard to be found by security tools. but with a lot of hard work put into it, you may get really nice exploits from looking into this. And this is just a first example, a warm-up vulnerability. The second vulnerability is it's a post-message vulnerability, post-message cross-site scripting vulnerability. I have presented in the past. I am really looking for post-message vulnerabilities and any DOM cross-site scripting, actually, because it allows me to do a bit of search code review and try to find something that a developer or maybe a simple software scanning tool would miss. Let's see if Zoom has actually a Zoom functionality, because I think you need to see this better.
Yep, okay. It works now.
It's better. Okay. Yeah, so the idea is that web browser windows have these on message listeners, which are triggered when the window receives a message from another window. It's an event listener similar with the onload functionality, or let's say with onClick or other JavaScript event listeners. But this is triggered when the web page receives a message from another origin, right? So what you should do when implementing such an event listener, you should first validate that the origin that is sending you the message is trusted, or one of the intended origins. And after that, you should validate that the message is something that you want to process further, right? And in this case, the origin validation was missing entirely. It's a way of saying that you accept messages from any origin, and the data was only processed against the regex vulnerability. In this case, it should have started with a special string, but after that there was no check for anything else. And based on the content of the data, you would fire one of the other functions built within JavaScript. This is not really obvious for a source code scanning tool, but during let's say interactive debugging, real-time source code review, you can easily find the details for such a vulnerability. And yeah, one of the functions that could be called would actually validate the origin, but in a really insecure manner. It would actually allow the star origin to send any messages, which is another way of saying that allow all is accepted. After that, the message would be processed in one of the listeners, as mentioned, the message handlers. And from the list of different message handlers, one of them caught my eye, the navigate function. The navigate function, which would open a new window based on URL that is contained within the message, right? So window.open is a known JavaScript sink for exploiting cross-site scripting vulnerabilities. It is well known that if you use JavaScript URLs, you are going to trigger a cross-site scripting vulnerability, which kind of no longer works in Chrome, but still works in a lot of other browsers. And in this case, you can see in the message sent to the window the format of the message. It would first start with the requested string to bypass that regex validation, and afterwards you would simply do JavaScript alert to execute an alert function, right? So why am I mentioning this this vulnerability, and why do I think it's hard work? Well, first of all, this vulnerability was not that obvious at first, and would not be obvious during a source code review if you are only using automated tools. There are tools out there which try to process the event listeners, try to give them input and so on, but it is very unlikely that there would be a tool out there that would bypass the regex validation, and afterwards it would guess the correct structure for the input message, right? Other than that, it's a vulnerability as simple as it can get, but not really one that you can find through automation. And there are tools which highlight that in your JavaScript file, there are a lot of, let's say, cross-site scripting things, functions which are dangerous to be used. But then again, in such a tool would output probably a lot of those things. It would not correlate from where each function is called, and it would be very hard just by looking at that list of things. It would be very hard to understand how to actually trigger a vulnerability using such a thing, right? But nevertheless, this vulnerability is in Mozilla Foundation, but it is a long time fixed, and that's why I'm showing the details. I did a proof of concept for it, just to be able to prove easily that this is exploitable. I would simply open in a new tab the vulnerable page. And after that, I would send to that new tab, I would send a post message with the structure that you've seen. What are the takeaways from this? Well, as mentioned, source code review can be hard work. It's not something that a lot of people go for. Usually, a lot of penetration testers want to remain in this area of let's say, input and output paradox, where you have a black box in the middle of it, and you simply try to give a lot of input and see what output you get in an interesting manner, right? But actually going into looking at the code gives you a lot of insights regarding how everything works, and you can try to exploit more interesting vulnerabilities. I guess source code review can be automated using really good solutions. There are a few out there. If you don't mind, I can mention checkmarks or Fortify or other solutions like this, but they tend to cost a lot of money. And on the other hand, I don't think they are reliable for such vulnerabilities. Even with their let's say, deeper understanding of the solution, they still cannot go into details and see when you can bypass something, when you cannot, what is the full stack trace for different possible bypasses, and so on, right? There are also a lot of differences between static code analysis and dynamic code analysis. For example, if I would only do static code analysis, I would probably never find such vulnerabilities. I would not guess which regex is used where. After that, which are the message handlers, where are they defined, and so on. So this is information you find when you are actually doing live debugging of the application, right? And this is probably the best way, because vulnerabilities are exploited at runtime when the application works, when it is in a clear state, not at scan time, where you can even have source code which is never reached, or source code which is imported from other sources, right? Okay. Another finding with a different story. This is the finding that I am most proud of, because it is my highest paying vulnerability to date. It is in the realm of thousands of dollars, and it was not an easy find. I did not find this through automation or enumeration, but through a lot of debugging and a lot of hard work put into actually building a proof of concept. The idea is that on the main website, not in an obscure part of the application, but on the main website, in the payment page, the website would include a payment timeframe for a payment provider, and the two of them would communicate through post message calls in order to, let's say, tell one to the other when the user entered something successful, or when the user did something wrong and there is an error in that page, and so on. So in this first case, we can see that the inner HTML DOM sync is used in the payment timeframe. So when the payment timeframe receives a message from the parent, it would take part of the message and it would add it to the DOM using inner HTML. This was a clear indication that the parent could trigger a cross-site scripting vulnerability within the iframe. But that was not of much use by itself, because the parent is a domain, a validated domain, one which is trusted by the payment iframe, and I could not send post message calls as the parent domain, only as a different website, as an attacker website. But there is more. The same post message listener was not available only in the payment iframe, but also in the parent iframe. It did about the same thing. When receiving a message containing an error, it would append that message to the DOM in an insecure way. The jQuery append function is another known thing for DOM cross-site scripting vulnerabilities. And yeah, so at this point, I have this scenario where the parent window can trigger a cross-site scripting within the payment iframe, and the payment iframe can trigger cross-site scripting within the parent window. But the two of them have a level of trust, and I cannot really get in the middle of it, because I'm a third-party website. I am not in the same origin as the parent or the iframe, right? So this was something that I discovered. I put my mind into how to exploit this. No idea came for a few days. I tried different things. I looked into what others are doing when exploiting such vulnerabilities. There was no idea for quite some time, right? Because in this trust relationship, I cannot interfere that easily. But after that, I've got an idea. The payment provider was not exclusively working with one program. In fact, as any payment provider out there, you can probably, with enough effort, you can probably integrate that payment provider into your own website, right? And when you do so, your own website can afterwards trigger the cross-site scripting vulnerability inside the payment provider iframe. Maybe the payment provider uses different origins or different subdomains for different websites. That was not the case. I've seen this only once happening, and that is not the standard approach. Usually, all the payment providers use the same origin when they integrate with different websites. This was also the case here. So the thing that allowed me to get a cross-site scripting inside my payment provider would also allow me to get cross-site scripting inside the target's payment provider, because they are the same origin. And if I hack one, after that, I have access to the other. And yeah, the last check was if I could use the cross-site scripting from my payment provider to trigger the cross-site scripting inside the target. And that was a success. I know this is hard to explain in words, so I try to to draw a few a flow of how the cross-site scriptings would go. So on the target, you could trigger the cross-site scripting from the iframe to the parent and from the parent to the iframe. After that, you could implement this payment iframe in your own website, and from there you could trigger the vulnerability in the target. That was the approach. And yeah, the hard work was actually at implementing the proof of concept, because integrating a payment provider is not as easily as it may sound, at least not in a test environment where you have a website without any product and you don't want to pay for anything. You just want for the iframe to get the card details to pop up. So that was a lot of going on implementing this. The actual implementation would simply include this payment provider in my website, and from there trigger the cross-site scripting in the target. But yeah, it took way more than I initially expected. From when I discovered the vulnerability, I think it took something like 2 or 3 days until getting the idea of how to exploit this. And from actually having the idea to making a proof of work, a proof of concept to actually work, I think it took me more than a week, due to how hard setting up the environment was. But in the end, it paid, and a lot. And not to mention that this was a vulnerability that was affecting not only one environment, but actually a lot of websites which were working with that payment provider, right? A few takeaways from this vulnerability for me. What I've noticed through time is that trust relationships, like the one that was between the payment iframe and the parent, such trust relationships are not easily understood by the automation tools. It's not that easy to explain in code what should be trusted and what not, right? And this is also a case when vulnerability, which was initially discovered in an out-of-scope place. For example, the payment provider's domain was not in scope for the bug bounty program. How such a vulnerability could actually be exploited through a trust relationship to affect your target, right? And in the end, it is also not clear where the trust should end and where you should end in your search, because in standard penetration tests, you have a clear scope and you know that you can only focus on that. But in real life, hackers are not limited by such approaches. They will simply find anywhere a vulnerability that is exploitable, and if it is something that it affects you, then they'll just go and use it, right? So the trust relationships should be only limited to direct dependencies, stuff which is evident that it affects your application, Or maybe should it also include the network infrastructure with everything that is hosting related, even if it is not clearly affecting your website? Should it also include the DNS configuration? And from the last few years that the subdomain takeover vulnerabilities are highly appreciated, which are not clearly within the scope, but they are affecting your main target through, let's say, the trust that the user has in another subdomain of a highly trusted domain, right? So it's not clear for me where the trust relationship should end. And more than that, we see how the industry treats different operating systems. For example, if you are using Windows on a desktop, then it's Microsoft's job to secure the environment, right? But if you are using Android on a mobile phone, then every application will try to treat the operating system as untrusted. They will try to check for root, to do root detection and to block the application from running if the Android system is rooted. But on Windows, you do have admin rights, right? They will try to do SSL pinning, so you cannot install your own certificate and inspect the traffic, although you can do that on Windows very easily. So there are different trust relationships with different components, no matter how far they are, right? This third vulnerability was the last one that I wanted to show, at least at this point. I wanted to talk also a little about how you can get better at finding such vulnerabilities, because it's not always that straightforward to understand. Usually finding vulnerabilities, let's say, a problem of pattern matching. For example, if you see a strange implementation and you've seen that in a similar way in the past, you know somehow that some types of vulnerabilities could be there. You can train your skills maybe using Hack the Box or similar platforms. There are a lot of them out there. So if you are into it, there are a lot of places where you can practice. In bug bounty, if you do not want to hack on very big programs, which are generally really hardened, you can try to start with smaller programs, maybe the ones that pay lower or the ones that don't pay at all, if that is something you are willing to do. But the approach I find most interesting is the build it, break it, fix it approach, where you build your own software. After that, you debug it, you test it to see what doesn't work, what the user could do to break it. And in the end, you have to fix it because it's your software, right? And what I like most about this approach is that it also trains your coding skills a little. So building a proof of concept for your vulnerabilities in the future would not be that hard. And it also gives you more insight regarding how security vulnerabilities could be built into your applications, right? Yeah, and once you have some experience with how vulnerabilities occur, a lot of time exploiting the vulnerability is just a matter of imagining how that could be done. And after that, putting the work into building a proof of concept that actually works is just a matter of time, right? How about getting lucky? Because the results are not always part of, are not in a direct correlation with the amount of hard work that you put into a test. Well, I think this is a case where you can try to make your own luck based on the build it, break it, fix it approach. You can become lucky if you test for crazy things, or if you imagine not so simple scenarios where something seemingly unexploitable actually becomes exploitable. And after you try to hack it and you have a first glance that it can be done, that the vulnerability actually exists, you have to put the work into building a proof of concept that actually works, right? I have one more vulnerability. This is fixed as of now, but not yet ready to be disclosed. I guess the company still wants to check if something like this is present in other parts of their infrastructure. It was present in a not so popular subdomain, so at least a bit of enumeration is needed. But finding this web page will not be that hard. The page would be an administrative tool built by the admin itself for sending email messages to their subscribers. So what this page would do, this page would allow the admin user to create an email template, and on the right part in the preview panel would allow the admin to see how that email message would look like when being sent to the subscribers. So it's fairly easy to see a cross-site scripting vulnerability here. You simply enter a cross-site scripting payload into the body, and that gets interpreted in the preview panel, and you have a cross-site scripting vulnerability. But here's the catch. This is a self cross-site scripting, right? This is something that the attacker cannot trigger for you. You have to write with your own hand the body image SR. You have to write the attack vector by yourself, which is something which is not acceptable in any bug bounty program, or at least not in the ones that I know of. I tried different approaches. For example, I was hoping that one of the get parameters might be reflected in the body field, and as such, I could transform this into a reflected cross-site scripting, but that was not the case. This is an example of a properly self cross-site scripting vulnerability where you cannot do much about it, right? Looking into the source code to see where the vulnerability relies was fairly straightforward. Basically, the input from the body text field would be added to an iframe using the source doc property. This would trigger the cross-site scripting, but again, it's still a self vulnerability. Well, let's put the work into it and make it exploitable, because it can be done, but using a few tricks and a few other vulnerabilities that were there. For example, the tricks that we can use to make a user write something into a body field. You can try to implement a CAPTCHA game where the user should write something that is displayed as an image in a text field to go to a next step, and probably the user would write something simple, but probably not, they would not write something as complex as an actually exploitable cross-site scripting vector, right? It's an idea, but it might work. You can also trick the user into copy pasting something into the field. And if what you are copying is the cross-site scripting vector itself, then this would be a method for the user to insert malicious code into the field. You can also try to trick the user to drag and drop something from another part of the page to drop it into the vulnerable field. But this becomes a lot harder because the vulnerable field, it is in a different page on a different domain. So you have to be really careful on how you instruct the user to do that drag and drop or the copy paste so that it actually still remains in the realm of possibilities, something that the user would normally do, right? Luckily for me, there are other minor issues within the page, something that would be out of scope for a bug bounty program. For example, the login and the logout CSRFs. Those are usually out of scope, although I would not let them be out of scope. In this case, the login CSRF was especially useful because the page would only be accessible to logged in users. So if the victim would be at a first visit on the page, they would not be logged into their session. So you would have to log them in by force somehow. And besides that, the page was also frameable, vulnerable to clickjacking, how it is usually mentioned. And it was only the case for this page. Something odd, because the main website, the subdomain itself would be protected against this. I guess being a custom-made page for delivering emails, maybe the developer felt the need to remove the framing protection to have the preview functionality working. That is just my guess, but yeah. Anyway, using those two minor vulnerabilities, I try to build a proof of concept and something that can be automated, of course. Trying to explain this proof of concept. In the first part, I have a form that would point towards the login, and I would actually first attempt to log out the user, afterwards attempt to log in, just to be sure that after the second step, the user is logged into a user account, and the vulnerable page is reachable. Afterwards, I would build into my own website a CAPTCHA game where I would, before another login on my own website, I would ask the user to perform some actions, such as drag and drop, where they would drag something that is defined on my website, and they would be instructed to drop that payload into the iframe, where the vulnerable body would be present. And yeah, that's the approach. You can see in the script tag that what I'm actually trying to drop into the text field is a simple cross-scripting vector. And I would listen for on drag events, and when that happens, I would replace whatever the user is seeing that they are dragging. I would replace that with my vector. After that, tricking the user into doing the drag and drop action is something that is user interface. Basically, if you tell a story that is nice enough, every user will follow and fall for this attack. And it's not just HTML. I also have a video for how this could be exploited. I'm hoping that you can see the video playing. So it just started. Can you see it playing? Maybe. Okay.
Does seem to work.
Thank you. So it seems like the user is simply introducing their username and password, and they will drag an image over an iframe, but it's not an image that is used in the drag and drop process, but it's actually the cross-site scripting vector that I replaced in the background, right? So let me show this again, because I think it's really nice to show how storytelling on a web page can actually trick the user into performing a malicious action. Inside the CAPTCHA test, with basically no visibility, here I have embedded the vulnerable page into an iframe. I made sure through padding that the body text field is just behind that CAPTCHA test field. Afterwards, dragging the cat image or any other image for that matter would not impact my payload at all. Because when the user starts to drag anything, I replace the content that is going to be dropped. I replace that with the cross-site scripting field. And when that happens, when the when the drop happens, then the cross-site scripting would actually occur, right? There is also a need for the user to click the login button or anywhere outside the page, because the cross-site scripting would only occur after the body field loses focus. So that is the final trigger. Anyway, I hope I did not bore you with those examples, and maybe made an argument on how hard work is still needed. So thank you for your attention, and I don't know if you have any question regarding any of the vulnerabilities or the projects themselves, or if you want to contradict me publicly, I'm fairly open to that.
Yeah, thank you very much for the presentation. It was really cool, and I think that payment iframe quite made a good return of investment of your time. So
yeah, it really did.
Was quite cool, and I think that's one of the key elements of making the awareness that automation is not complete without actually going manually and looking into the bugs, because like you said about IDORs, also, for example, that one cannot be automated. So you need to go manually and look for those bugs. And we have also a question here. So you find bugs with manual code review, like a like a psycho?
Yeah, let's say that it's obvious why people tend to avoid doing code reviews. A lot of the code that you see in production is already minified. It's actually obfuscated to hide any proprietary use of it. So I understand why that is hard. But then again, there are people that are doing debugging and looking into assembly code for fun, right? I'm not the most psycho in the industry.
Yeah, many will argue that if you have SEAs, composition analysis, if you have SAST, but then you're quite safe to not go to manual review all those applications. But yeah, those are good examples that pays it off. But how you can convince? Should be there any I don't know, more awareness into the bug hunters or into the security community that we should do this more, not only rely on because if you are looking to maybe HackerOne leaderboard or other leaderboards, you will see lots of people that are now relying lots of on automation. I don't want to give names. You just go on Twitter and you will find.
Yeah, you are right. Actually, the top guys within the industry, they are doing just that. They automate a lot and find a lot of vulnerabilities based on that. But well, that didn't really work for me. And let's say that behind the vulnerabilities that can be found through automation, there are also a lot of other issues that should be searched for. Because really motivated attackers will not stop at just scanning with tools and looking for low-hanging fruits, right? They will go deeper. If you are let's say, big enough company which is trying to protect their assets against malicious actors, such as state-sponsored attackers or big malicious groups, those types of attackers really know what they are doing. They'll search for the lowest vulnerability, they will make it exploitable, and they'll use that against you. It's simply not enough just to rely on automation and just scratching the surface, right?
Yeah.
And yeah, there are also a lot of vulnerabilities which are found, let's say, by mistake or through crazy amounts of imagination. But those are not the norm. You are right here. Yeah.
And we have a question. Is where we can read more about the DOM-based XSS, similar to your case study. Because yeah, I quite agree that it's quite complex.
It is still not public. I will push to make it public soon. Basically, it does not depend on you and me, because at least the payment iframe vulnerability that was present in a lot of websites with different implementations, and it would be responsible from my side to push for a disclosure before being sure that everybody upgraded. But for such types of vulnerabilities, there are a lot of talks on YouTube. From time to time, you can see on HackerOne report showcasing a post-message vulnerability. It's not really a new issue or anything like that. It's simply something that people are not searching for enough, I think.
With regards to working smarter, if I may, I would raise some points, maybe just for the sake of the argument. So in many of the cases, you know, you might have access to the source code because there are a lot of open source libraries which you can, you know, deploy yourself and so on and so forth. And they are being heavily used by a lot of companies. What you can do is, for example, use SAST as, let's say, the first tool, just to find sinks, CWEs, potential vulnerable functions, and so on and so forth. And then you can use maybe fuzzing with code instrumentation and see, you know, which payloads do get to that certain point that you are looking for, right? And also maybe you could also use, let's say, a newer approach like IAST, interactive application security testing, right? And that way, let's say it would save you a lot of time, which is, you know, which would heavily improve your productivity. And besides that, you know, after, let's say you have worked harder, like you just did and showed, right? What you can do is you can use automation to scale. Well, first of all, to create a regression test scenario that you could reuse within your, let's say, company, so that you would make sure that that type of vulnerability would not happen again, would not be introduced again. And besides that, you know, there are a lot of, if you would want to scale up, if there are, you know, a lot of servers that replicate load balancers, fail-safe servers, public-facing test environments, and so on and so forth, you could really easily, let's say, retry the, let's say, exploit that you have just created without too much effort. You know, you won't need to do manual labor in order to get there, and that could save you a lot of time and effort.
Thank you for your input, Istvan. You are totally right. I mean, the point of the presentation is not to exclude automation as a tool for being more productive. I would say that you can also use it a lot in cases where you want to see if the same vulnerability replicates in other environments. You can use automation to search for different targets that have the same component and so on. So it definitely has its place within the whole process. The idea I was trying to highlight was not to rely only on that, but also go deeper than the tools are actually allowing you to do so. And the thing is that what you mentioned, using automation to further see if this is exploitable on other targets or on regression testing, this involves some coding from your side, which is totally fine to do. The problem within the industry is that a lot of people are relying on tools that are already built by other people. They are not customizing the tools, and they are simply using them to blindly scan the entire internet, right? And that's just not an approach that that is really productive by itself.
Yeah, I can tell you a lot about that. Actually, we are creating. I'm working for Project Discovery. I don't know if you have heard about them. Maybe
Yeah,
Alexis will mention a couple of our tools within his workflow, right? And there are a lot of people using Nuclei or vulnerability scanner blindly. So that's not what we intend with our tools to promote. But that's another discussion. I will let Alexis, get into the details on that.
Thank you very much, Daniel. If there are no questions, then the stage is yours, Alexis.
So, welcome to my talk about Recon tips and tricks. In this talk, I will not be focused on automation or explaining how to do the better workflow or whatever for automation. I will be jumping over different topics related to Recon that maybe could be useful even for Daniel. Just for improving your workflow, but not telling you how to do the things exactly, because this can be used for a lot of different things. My presentation, my handle on most social media is 6todeath. My name on real life is Alexis Fernandez. I'm from Madrid, Spain. I work at the Visma's red team, and in my free time, I work on Cobalt Core and Synapse red team. My website is 6todeath.com, where is the pentest book also. And I'm the main developer of Recon for the Win and One List for All. Recon for the Win is a Recon framework mixing different tools and techniques. Basically, it's a bash script piping a lot of tools, and I created a specific workflow for the Recon. And One List for All is a bunch of word lists for web phasing. So let's start the thing. This is the index for the presentation. I hope some of this could be interesting for you. The first topic will be about the subdomain passive tools. As you may know, when we are working on subdomain search, we start doing subdomain passive discovery, relying on third parties, different providers like Security Trails, Census, Codon, Virus Total, whatever. And the thing is, all of this works with a expense token model, where they token are burning at the same time that you are fetching data. When different days, weeks, or months pass, that token model is refreshed, and you can start again with all your amount of data free. The thing is that most of these third-party services only speaking about subdomain discovery provides almost the same data. Approximately 70% of the subdomains fetched from Security Trails, Census, and the others are the same. And when we fetch this information, we rely on different tools from pre-discovery, for example, like SubFinder or AMAS, One for All, SubLister, FindDomain. There are a lot of tools. Okay, I see a lot of people using all these tools at the same time for the same target, using AMAS for OWASP.org, SubFinder, Acrobat, FindDomain. Okay, where is the problem here? All of these tools are using the same third-party providers. So you are spending your tokens over and over on the same target, and it has no sense. So my advice here is to only use one tool for subdomain passive discovery, because you don't want to spend those tokens that you are paying or your company are paying, or if you are using a free subscription, you are burning your tokens. So this is a caption from a Subdomain's review tool that I did for Yes We Hack blog, and this is all the third-party providers. This is the most common tools for this topic, and here are the amount of providers that its tool are parsing. So I'm not saying you that only use AMAS, but use only one for this because it's totally useless. You can use SubFinder because it's pretty much faster than AMAS, but the thing is only use one, please, because it's completely useless. Sorry. And this is the first tip. The next. Yeah, I prefer AMAS over SubFinder because it can be used for a lot of different things apart from subdomain discovery. Most of us only use for passive discovery, but since the 3.17 version, Jeff Foley, the main developer, built a DNS resolver from zero, written in Golang, for AMAS to not rely on mass DNS, for example. And since this version, since 3.17, the DNS resolution on AMAS has been improved a lot. It's really faster and it works really good. So in this second slide, my tip is to give it a try to AMAS on all the topics related to subdomains because it works really good compared to using AMAS only for passive discovery and piping the results, for example, AMAS, piping to pure DNS to resolve the domains, and then start doing DNS brute forcing and permutation. All that process can be done only by AMAS and with really good results. If you are not familiar with AMAS, I put here a command line for AMAS to perform all the things in just one line. This is AMAS using the enum module, specifying the domain target where you can scan. You can determine which subdomain list do you want to use for subdomain brute forcing. The same for permutations. You can set which permutation list do you want to use, but AMAS has one permutation list included itself. And then you can use your custom resolvers list and your custom resolver trusted list. If you don't know what are the resolvers, in the next slide we are going to talk about that. And you can define rate limits for the trusted resolvers. In this case, this stands for trusted resolvers queries per second. And finally, instead using the /o flag, which just returns a file with a txt file with the results, I prefer to use the /dir flag because it outputs the same txt file, but also a JSON file including more information. For example, the origin where that subdomain has been found, for example, from permutations or for brute forcing or whatever, or if it comes for one passive source, it will tell you which third-party provider has returned that subdomain. So this is the thing. Start using AMAS for other things than passive subdomain discovery. Okay, the next is talking about resolvers. This is how it works, the DNS resolution. When we do a DNS request, we ask to a DNS resolver to talk to different servers to return you the response if that subdomain is alive or not. Okay, we are using those DNS resolvers for DNS resolving or DNS brute forcing. Okay, and we can split those resolvers in standard resolvers and trusted resolvers. The standard resolvers, we call this to all the DNS servers, all the public DNS servers across the world that you can make a request and they will respond to you if that subdomain is alive or not, or whatever DNS query you perform, they will respond you. Okay. When we have to resolve, let's say, millions of subdomains because we are using a brute force list or we are performing permutations and we want to check if any of these is alive, we can't use only one DNS resolver because most of the resolvers has a rate limit. So we can perform, for example, 2,000 queries per second against any DNS resolver because first of all, he will start thinking that you are attacking him, and then probably he will ban you or he will start responding with false positives and or false negatives, which will poison our results. So to avoid this, what we want is to create a word list with different IPs for all the public DNS resolvers across the world to send, to spray all the requests over all the DNS servers to have the response for all the subdomains in the fastest possible way. When we have this result, we will do a second check against the trusted resolvers. The trusted resolvers are DNS resolvers from large companies. For example, Google, 8.8.8.8, Cloudflare, Quad9, OpenDNS. There are like 6 or 8 organizations which are providing the DNS server, and most of the applications rely on them. This is why we consider them as trusted resolvers, because we think that they will always answer with the correct response. So we will do first resolution against the resolvers, the standard resolvers, and that results will be checked against the trusted resolvers. This is a test that I performed yesterday with 7,000 resolvers. I was getting response at a rate of 20,000 queries per second. With only 200 resolvers, I was getting the response at 1.5 thousand queries per second. And how can we get this resolvers list? We have two options. We can create for ourselves or download any resolvers list out there. For example, DNS Validator, it's a project where you can give them an IP list, and DNS Validator will perform different checks against that IPs to check if those IPs are responding to you, because there are some country restrictions that you probably know at this time. And for example, if we are at Russia and want to ask to a DNS resolver from the United States to respond us, maybe it will not respond us. So we can use that IP or that DNS resolver. And DNS Validator is the task that it does. Perform different checks against all the IPs, and then it returns you an IP that you can use as custom resolvers list that works for you at that exact time. If you don't want to use DNS validator, it takes like 10-20 minutes to create the WoW list. You can download one from GitHub. There are a lot, but the best, in my opinion, is the one that Trickest has in its resolvers GitHub project. Basically, they are running with his automation platform DNS validator every day, and they are pushing to the repository a fresh resolvers list each day, both the standard resolvers and the trusted resolvers. So we can rely on them to not have to generate that list every day or every time we want to perform DNS resolution. So the tip here will be use a good resolver list and be aware that as much resolvers you use, much faster you will resolve that subdomains list. Okay, this is an interesting technique to for subdomains and domains discovery, which is TLS handshake domain scrapping. This is the TLS handshake protocol where we ask to the server, hey, are you there? Yay, hey, I'm here. Okay, can you send me your certificate? Yeah, sure, here it is. Okay, in this step, we have the server certificate, and we can check in this exact moment the domains and subdomains included in that certificate. So this is something similar that HTTPX does with the TLS grab and TLS pro flags are doing, but the difference with this approach is to grab the certificate for every port running a service with a TLS layer. So this is not exclusive for websites. Okay, according to the standard IANA list, there are more than 140 TLS port serving a service using the TLS layer. So we can fetch this information from secure FTP, SSH, or whatever protocol and service you can imagine using this protocol. And of course, there is a tool that performs these checks called Zero. It's written in Golang and works faster and good, so we don't need anything more. And this is one trick. I think not much people use this technique for subdomain scrapping, and it's pretty interesting. Okay, the next is, oh, of course, JSON is love. How to say about JSON? Okay, first of all, JSON stands for JavaScript Object Notation. And I think most of us know what is JSON. This is how JSON looks. It's really easy to read for humans and really easy to parse for machines. And there are a lot of tools using JSON as option for the output, like AMAS, FFUF, Harvester, MassScan, and I think all the project discovery tools has this option. And the best tool to read and extract query information from JSON is JQ. For this demonstration, or to make you aware of how powerful is JSON, we have this JSON file from HTTPX where I fetched I can remember dozens of websites from book crowd, let's say 50, for example. And this is one example of how can we use JSON and JQ. I have this file and I want to extract from that HTTPS JSON file, which contains all the information about the book crowd sites. I wanted to extract only these 3 sites. I want to extract the information of that JSON file or of only these 3 sites. Okay, with this for loop, we read the previous file, temp/https.json, and we define on JQ an argument that we call test, and it will have the value of I from the bash for loop, and we just order to JQ to select from that JSON all the rows which the URL is the same as the argument test, and just print it. This JQ -c is just for compress output, just to can read here in this caption, and that's it. We are extracting only these 3 sites from the JSON file, and here I have one a bit more complex. This is from mass scan JSON output. The mass scan JSON output contains 1 JSON line for each host. So what I want to make you be aware is I have this temp mass scan.json, which is imagine 1 port scan from the last month, for example, and I have this temp mass scan 2.json, which is a port scan from yesterday, and I want to compare them and extract from that comparison only the new ports, only the new findings. Okay, so I do a comparison from the first file. I want to format the data to be able to compare it easily. So what I want to do is extract the IP, put a colon, and then grab the port, again another colon, and after that the protocol. So I will have IP, colon, port, colon, protocol, and I want to sort it. Okay, the same for the second file. Read the second file and format the output in the same way. So we will have 2 lists with the same format, really easy to read and compare, and then make the comparison. Here ends the comparison. I want to sort the results, and with JQ again, I want to format that data because I want to pipe it to another tool, or I want to save in this specific format, and I want to print a JSON structure with each line starts with the IP, and I want in a nested group the ports and the protocol for that IP. And here is how it should work. From the input, here I want to create the IP key, and I want a nested group called ports, where it will contain the port and the protocol. And here is the result. So in this example, we are formatting 2 different JSON files, comparing them with bash, and after that, formatting again with JQ to return a totally different output. And this is why I love JSON, because you can create a lot of structures of data and fetch the data like you were using any query language, just with one file. sorry, here the tip is start using JSON for everything. Next topic, Google Analytics. This is a technique, again, for domain and subdomain discovery. If you never used Google Analytics, this is a service from Google to have all the website stats in a fancy dashboard where you can see where are from the people visiting your page, when are visiting it, with which devices, the typical stats, okay, about your public in a website. When you start using Google Analytics, they provide you a Google Analytic ID, and that Google Analytic ID is for all your websites, all the websites belonging to a specific Google account. So we can think that if I'm at the webmaster or sysadmin of a company, I will be in charge of creating all these things, and all of them will be using the same Google Analytic ID. This caption, this piece of code, is the example provided by Google to start using Google Analytics in your site. You have to load a JavaScript file when the page loads. So what if we can recover the Google Analytics ID from any page, and we have a relationship between the Google Analytics IDs and the domains using that Google Analytics ID? Okay, that's what actually happened. BuildWith is a service with this database, and this Google Analytics ID belongs to HackerOne. And here are the domains owned by HackerOne using this exact Google Analytics ID. Most of them are pretty obvious, like HackerOne, support.hackerone.com. But for example, HackerOne status, maybe it's not something that all the people knows. The CTF that they hosted. There are some interesting things, and this phase is not only interesting for subdomain discovery, but for domain and maybe even companies belonging to an organization will be useful also for that purpose. And as always, there are a tool that try to access a website, read all the JavaScripts loading in the beginning, try to recover the Google Analytics ID, and request the information for BuildWith, and returns in the terminal, and it's called analytics relationship. This is another different trick for domain recovery. Okay, another one. We all know Wayback Machine or archive.org, and we know how to use it. It has a lot of information, and here is the combination of Wayback Machine and the file robots. We all know what contains the file robots, and we all want to check all the disallow entries on the robots file. Okay, if we mix these two things, recovering all the disallows entries from all the historic robots file for one specific site, we will have an interesting word list for fuzzing. And this is what the tool RoboExtractor does. And with this specific technique, I have found sometimes different hidden endpoints. You know that organizations using security by obscurity. Okay, we are here for this. And yeah, this is another interesting trick, mixing these two things, Wayback Machine and robots. And okay, this is the last one. This is as the previous one. It's a combination of two services. When you don't have the hashed subscription, or when PoundDB in Tor is down like the last weeks or months, I guess, and you want to check if there is any password leaks for that target that you are auditing or hunting. This has given me some nice credentials working. The thing is, when we are using, for example, have I been Pound, they told us if our username password has been leaked. Okay, this service, bridgedirectory.com, has the same purpose, but they give also the hash for the passwords he found in the data leaks. Okay, if we combine the hashes that he is providing us with hashes.com, and we all know that most of the people are not using super complex passwords. Here we have all the plain text passwords from generic user OWASP. It's another technique. I like to know some different techniques for some different things. And this is one, I think it's fun, this one. And this is the end of the talk. Do you fall asleep?
No, not at all. So thanks a lot, Alexis, for the talk and for the tips and tricks. Really, really useful. We had a question in regards to the normal resolver list, but I think that you answered. If not, Shivam can raise again the question if he wants.
I can read the chat.
Yeah, it's the difference between the trusted and normal resolver list, but I think that you answered it, if I'm correctly.
I can answer again. The normal resolvers list will contain a public resolvers list across the world, but they can belong to a small corporation, or it can belong to a country or any company. We want to use it just to give a response, but you always want to do a double check against the trusted resolvers, because we rely in the trusted resolvers to get the last good answer for the DNS queries.
How to maintain the balance between Nmap, masscan, and if there is any better tool for port scanning?
For port scanning, I'm an Nmap guy, but when I want to scan a large amount of IPs, I rely on masscan and then Nmap for service discovery. Using masscan only to check which ports are open, and Nmap to fingerprint those ports. But I always use Nmap because I think it's the best tool for port scanning.
I assume it also depends what is your context, because in certain cases you could also just rely on, if you do not want to make contact, you want to be stealthy with the targets that you are trying to scan, you can also use show them for that. And we actually added this support in Nabu, if you're familiar with the tool. It's our port scanner. It's also quite fast as well. So it depends, what do you want to achieve. If you also want to, let's say, access targets using, you kind of made a comparison with MS and Sublister and Subfinder and so on and so forth. It again depends on what do you want to achieve. You can use, if you have the time and so on and so forth, you can use MS, right? And it would take you, I don't know, 20 something minutes to to get some results. But if you need something faster, or your context is, let's say, stricter to bounty, let's say bug bounty targets, then you could use Chaos, for example, or even Subfinder. And in those cases, you know, where you were showing some JQ magic there, we try to do, you know, with our tools, some filtering options to give out to you. And in comparison, you know, we are trying to build our tools, let's say, to be modular, so they can be reused even as a library and so on and so forth, letting you to connect those tools together in order to build a full flow, for example. And by the way, this is not yet public, but since you were, let's say, mentioning TLS, you can keep an eye out, because in the next couple of days, we are going to also release a new tool called TLSX, which is going to be, you know, quite similar to DNSX and HTTPX, but we'll have a couple of cool features and surprises.
Perfect. I will give it a try.
Also, we have a question from Daniel. It's how much actually you're paying, Alexis, for the paid discovery services, or do you try to avoid them?
No. Depends. For example, for HTTP probing, I love HTTPX. I think it's the best tool, and I use it a lot. But depends. For example, for me, I used Nabu a couple of times, and I feel the results are not. How do you say? It vary on the results that it gives you when run scans over the same host over and over. And in my opinion, Nmap is more stable when it performs different scans. It's just my opinion, and everyone has its set of tools. But yeah, I try to use the best tools that works for my workflow.
Yeah, actually, with regards to Nmap versus Nabu, you know, our intention was not to replicate, you know, Nmap functionalities. We just needed something blazingly fast to do some sync connect scans. And actually, we do have the option to run Nmap commands throughout Nabu. So it wasn't, let's say, a tool to replace Nmap. And so you get the point.
Yeah, on the first version of Recon for the Win, I was using Nabu for port discovery, piping to the Nmap command feature that Nabu has. Sorry?
There is one more question.
Okay.
If you use any word flags with Nmap?
Depends on the scenario. If I can go with just sync connect port discovery, depends on the scenario. I like to dig deeper in the different flags of Nmap for example, firewall bypasses and all this, but I don't have a specific set of flags that always I use. Depends on the scenario.
That's all for participating today, and most probably next time we will meet physically in an office. So somewhere maybe the end of September or around September. But thanks, Daniel, for your talk, and also Alexis for your talk, for really cool presentation, really cool tips and tricks. Also for the reconnaissance, but also doing the hard work of finding the bugs manually. So are really cool two topics. So thanks both, and thank you all for being with us today. See you next time.
Thanks a lot.
Bye.
Bye.
Thank you.